Welcome to today's calculation lesson. Please get your pen and your paper to jot down whatever you understand in this lecture. If you need help, okay, you are a last minute preparation candidate, you want me to help you, or you are a Jamb UTME candidate, you want me to help you, you know that I am the talisman now. I am the master, okay, the master of last minute preparation, the master, the best educator in Nigeria. That's who I am. All right, whatever I tell you I am, that's what I am. All right, so hit me up on WhatsApp. You need all the materials you can get. I don't have long material. All the materials I have are straight to the point. Okay, straight to the point, tailored from Jamb UTME syllabus. So do well to get those materials, get everything, and allow me help you to pass. Okay, it doesn't matter if you have 2 weeks left, 1 week left, I can still help you. All you need is the last minute preparation plan. It's just 4-page documents that shows you how to do less and score more in Jamb UTME 2026. So do the needful. This is the number, this is the contact. Connect with me, connect. Without wasting much of our time, let's look at what we have here. The gas law. Remember, the gas laws cut across chemistry and physics. So if you know them now, you are going to see questions from it in physics. This one is Shaw Banker. You are going to see questions from it in physics, and you are going to see questions from it in chemistry. Okay, so let's learn, because I am going to treat this just once because it applies to physics and chemistry. That's like double mark on both sides, both aspects, both subjects. So let's go. The question we have here under Boyle's law, the first gas law. The question reads, Jamb must repeat question 1. A gas occupies 12.3 liters at a pressure of 40.0 millimeter of mercury. What is the volume when the pressure is increased to 60 millimeter of mercury? Constant temperature. So the temperature is what? Constant. That tells us that is what? Boyle's law. You are trying to tell us that the volume of a gas, which is this 12.3 liters at a pressure, this particular pressure, this is the first pressure, and they are asking us to find the final volume. They already give us one volume here, which is the initial volume or the first volume. They are asking us to find the second volume. All right. So what are we supposed to do? We are told to find volume, second volume. They already put one volume for here, which is the initial volume. They told us to find the final volume. They now told us to find the final volume. So we write what we were told to find. Given this is very easy. I make complex calculations and subjects. I explain them easily, and I give you a renewed hope. All right. So given what, I will show you the shortest cut to solving all this. No need to distress yourself. The shortest cut now I want to give you. So we are told to find what final volume, which is V2, the second volume. It's equal to question mark. That's what we are looking for. Okay. The second thing to do, look at the options. What are the options represented in following the 11 steps of answering calculation questions in physics and chemistry? Okay. All options presented in liter. That's to tell you that it's volume. It's talking about volume. Okay. Liters. All right. So and all of them are decimal. So what do we need to do now? We need to write out the formula of what we have to find. Okay. What is the formula for Boyle's law? Okay. Inverse proportion of volume and pressure. So that gives us P1 V1 is equal to P2 V2. So since we are looking for volume, V2, we are supposed to make volume the subject of the formula. But forget about subject of the formula for this one. I will teach you the shortest cut. No need for that one. First of all, the next thing to do, let's write out all the parameters given to us. A gas occupies 12.3 liter. That's this one is the first volume, V1. They give us V1 equal to what? First volume, 12.3 liters. Okay. At a pressure of, this one is first pressure. Okay. First pressure, P1 equal to what? 40.0 millimeter of mercury. Okay. They give us what again? Okay, what is the volume? That's the V2 way we define. When the pressure is increased to 60 millimeter of mercury. Okay, this one now is our pressure 2 now. Pressure 2 equal to 60 millimeter of mercury. Okay, so the next thing to look is, let's look at if we need conversion. For Boyle's law, most of the time we don't need any conversion. Okay, now for Charles' law, we basically get temperature in Kelvin. Where we need to convert degrees Celsius to Kelvin. That's if they don't give you in Kelvin, they will give you for degrees Celsius. You convert degrees Celsius to Kelvin, which is very easy. I already taught you how to do temperature scale conversion. Just plus, okay, plus with 273 and you get your Kelvin. That's it. Plus the value with 273 and you get your Kelvin. So we have to solve now. So we are supposed to make this the subject of the formula. All those one are waste of time for inside examination hall. As it is like this, so put on. As it is like this, so insert all the things you get for here. Okay, what is P1? What is P1? P1 is what? Substitute 40 times V1. What is V1? V1 is 12.3. 12.3. Put our equal to. The next thing we'll get there now with P2. What is P2 here? 60 times V2. Okay, just solve like this. 40 times 12.3 is what? 492. Since we have equal to sign here, we put our equal to sign. 60 times V2 will give us 60 V2. So what do we do now? Since we have V2 here, and it's not a number, it's just V2, and the rest are number, what do we do according to mathematics? We divide both sides by the coefficient of V2. 60 V2. 60 V2. As easy as that, easy. V2 cancel V2. 60 into 60 will give us 1. That one don't go. 60 into 492 will give us what? 60 into 492. We bring down this V2. V2 come down. Is equal to, this divided by this will give us 8.20 liters. So look among the options. Which option among the options has this value? 8.20. Drop that option in the comment section. See you in the next. Still under gas laws, we are looking at general gas law today. Okay, general gas law. Okay, and the question we have in front of us here is Jamb must repeat question 2. Don't joke with my Jamb must repeat questions. Take them seriously. Okay, Jamb must repeat question 2. The question reads: a given mass of gas occupies a volume of 200 cubic centimeter at temperature 27 degrees Celsius and pressure 380 millimeter of mercury. Calculate its volume at STP, standard temperature and pressure. Standard temperature equal to 273 Kelvin. They even give you standard pressure equal to 760 millimeter of mercury. They even give you some questions, they will not give you, so you have to know all the standard temperature and pressure. You have to know both. Okay, so among the options given, all options are represented in what? Cubic centimeter. Okay, with some decimal, some are decimal, okay, and some are round figure. So let's see what we can do here. First of all, we have to look for what they told us to find. What did they tell us what we find here? Now they told us to look for what? If a gas calculates its volume at STP. Its volume, they give us any volume before as first volume? Yes. Look at it. If a mass of gas occupies a volume of 200 cubic centimeters, so this one is V1. So we are asked to find V2, giving V2. Now this one we define V2. All right. Since we are looking for V2, we are supposed to write out the formula. But for us to know the suitable formula to use here, let's write out all the parameters given to us first. They gave us V1, which is volume of 200 centimeter cube. So the first volume or the first temperature or the first pressure is the first pressure that is mentioned, okay, in the question. The first one mentioned is the first, okay. The second one mentioned is the second, okay. If they mention one and they tell you to find the other, it means you should find that one. It's that one that is missing, okay. So V1 is equal to 200 cubic centimeter, okay. Which other one again? They gave us at temperature T1, 27 degrees Celsius. T1 is equal to 27 degrees Celsius. We have to be very fast. And pressure, 380 millimeter of mercury. Okay, and pressure, this one now P1. P1, they never mentioned pressure before, equal to 380 millimeter of what? Mercury. Then the next one, calculate its volume at that. We are calculating V2. We already have it here. Okay, so if you look at these parameters given to us now, we have volume, we have temperature, and we have pressure. Which formula combines volume, temperature, and pressure together? Is the general gas law. General gas law combines Boyle's law and Charles' law together. It combines Boyle's law and Charles' law. Remember, Boyle's law is talking about volume and pressure. Charles' law is talking about temperature and volume. All right, so that's that. So, but here we have volume, temperature, and pressure. We have everything. So everything combined together. So we are going to use both Boyle's law and Charles' law, which is the general gas law combined together. You combine Boyle's law and Charles' law together. What is the general gas law formula? The formula is P1V1 over T1, sorry, equal to, you will not do everything P2V2 over T2. You will not join this one together. Join it together. Make what you are looking for the subject of the formula. But I will give you the shortest cut. No need for subject of the formula. No need for joining anything together. Just apply normal arithmetic and you get your answer. All right. But looking at what we have here, okay, we have temperature here. Remember, when you have temperature, apart from Boyle's law, if you are solving Boyle's law, for example, Boyle's law has constant temperature. Okay, there's constant temperature. So temperature is not involved in Boyle's law because the temperature is what is constant. Okay. If you are solving other ones like from Charles' law, general gas law, and so on and so forth, always convert your temperature to Kelvin. That's number one. And here they said at STP, meaning this pressure. Look at the pressure. Can you see the pressure? This is the standard pressure. This is the what? The standard pressure. This is the standard pressure. So this standard pressure is now going to be our P2 because it's standard pressure. P2 equal to 760 millimeters of mercury. So this standard pressure is now our P2. So they gave us two pressure. They gave us pressure 1 and standard pressure. All right. So what we are left to do now is to convert this T1 from degrees Celsius to what? Kelvin. To convert from degrees Celsius to Kelvin is Kelvin is equal to degrees Celsius plus 273. This one, the formula easy. Kelvin is equal to 27 degrees plus 273. That will give us equal to 300 Kelvin. So 300 Kelvin. Okay. So this one now will now be 300 Kelvin. That's what it's going to be here. Let's put it equal to 300 Kelvin. All right. So what we have to do is substitute into this formula. Okay. So what is P1? P1 is what? No need to make anything that you are looking for the subject of the formula. P1 is what? P1 is 380. 380 times V1. What is V1? 200. Okay. Over. What is T1? T1 is 300 Kelvin. Now 300 Kelvin. Can you see? No need to put this Kelvin. So while I was doing this video, my phone just suddenly stopped recording. Okay. So I've already solved and arrived at the answer, but I'll walk you guys through how I got the answer. Okay, we were talking about conversion. Okay, conversion of degrees Celsius to Kelvin, which we did here. You can see, and we got 300 Kelvin. Look at the conversion here. 27 plus 273. That's how to convert from degrees Celsius to Kelvin. And we got 300. Okay, so that's our T1. Then you can see our T2 is equal to our standard temperature. Okay, this is the standard temperature they give us. Since they give us at STP, that standard temperature is our T2. That's why we placed it here, 273 Kelvin. All right, so substituting into this formula we have here. Okay, no need to rearrange, no need to do subject of the formula, just substitute straight. Okay, that's how I teach it. All right, so what is our P1? Our P1 here is 380. P1 is 380 times, what's our V1? Our V1 is 200. Okay, over, what's our T1? Our T1 is 300 though, 300 Kelvin. Look at it here, 300 Kelvin. Then equal to, what is our P2? Our P2 is what? 760 times V2. That's what we are looking for. V2, we have no V2 there, that's what we are looking for. Then over T2. What is our T2? Our T2 is 273. All right, this is what we have. So if you solve here, this times this divided by this will give us the calculator says 253.3. Okay, what we are doing, just divide straight, no need to stress yourself, just divide straight. This divided by this will give us 2.783. Okay, so we are left with both of these V2. Since we have V2 here, we are going to divide both sides by the coefficient of V2. Okay, so dividing both sides by the coefficient of V2, we'll now be left with 253.3 over 2.783 V2. You put the same thing this side, 2.783 V2 over 2.783 V2. This cancel out this divided by this, bring your V2 down. V2 is equal to, this divided by this will give us 91.9 cubic centimeter. Pick the option among the options provided and drop it in the comment section.